back to a lecture series on hydrogeology. So in this lecture, now we are going to discuss about the graphical interpretation of water quality. The title of the discussion is Gibbs diagram. As we have already discussed, numerical numbers could not be able to display very correctly for the quick interpretation. Visual impact is more clarity than the numerical numbers in the tabular form. So this is a known factor to us. Many scientists have come forward to explain the application of graphical interpretation for various uses. So in this line, Gibbs diagram is my discussion of the topic today. So it is in the year 1970, Gibbs diagram is used to assess the controlling groundwater chemistry quality. After taking the output, this is the Gibbs diagram, and when you plot, you will be able to know the chemistry of water. Is it controlled by evaporation, or the chemistry of water is controlled by rock dominance, rock water interaction, or is it due to precipitation? So this diagram is widely used to establish the relation between the water composition and the aquifer lithological characteristics. Normally, if the sample falls within this, sure you can conclude that your interpretation falls with respect to geogenic sources. Lithology is the source behind the enrichment of chemistry of water in that particular area. It illustrates three mechanisms that regulate the chemistry of water. One is rainfall precipitation dominance. Second one is evaporation dominance. Third one, rock water interaction dominance. Area are shown in the Gibbs diagram, Gibbs 1970. So here this is for the cations and this is for the anions, and the sodium plus sodium over sodium plus calcium is taken, and the total dissolved solids in milliequivalents per milligram per liter is taken, and this is EPM data. And once if you plot your analytical output, then we will be able to interpret. So this is the graph which was already set at the back side. Only now we are going to take the samples and plot it in this diagram to assess what is the movement, whether it is moving from evaporation to rock dominance, or the rock dominance to rainfall, or rainfall to. If you do it for 2 seasons, we will be in position to assess, not with only 1 season. Once we plot the first season and the second season, maybe the influence of the season will bring, or from rock dominance it moves to rainfall during post monsoon, then we will be able to say that it is controlled by meteorological water. Many aspects of the overall mechanism of groundwater are still poorly understood. Yes, still many cases we will not be able to understand why it is, and you see even this diagram represents very clearly that it is due to rock. And then for taking sodium and potassium over sodium, potassium plus calcium, and by taking chloride and bicarbonate, and then you see this is moving from here to here. It is 100% dominated by the rock in the particular area. So he has suggested, Mr. Gibbs suggested that a graphical diagram to understand the water chemistry relationship of the chemical composition with respect to the chemistry of rock type, with respect to the chemistry of precipitated water, and the rate of evaporation. So you will have to take in x-axis as your ppm value, and then y-axis milligram per liter, that is the ppm of total TDS, and then plot it x versus y, and then you will be able to assess accurately with respect to the dominance of the water chemistry in terms of rock, or in terms of evaporation, or in terms of precipitation. The Gibbs plot depicted that the chemistry of water were modified by chemical weathering. I mean, plotted by precipitation is a major factor controlling the chemistry of surface water. Based on Gibbs variation ratio 1, that is anions dominated. This is, you see, they have taken chlorine over chlorine bicarbonate and TDS anions, and they have also taken sodium plus potassium over sodium plus potassium plus calcium, This is represented in x-axis and this is represented in y-axis. Actually, this diagram is the exact diagram what one has to do, and you have to collect the samples at different stages. Like deep water, you have to collect, like you have to collect surface water and you have to collect shallow water, and then see what is the difference between shallow water, deep water, and surface water. Then only we will be able to understand that the movement, because you cannot take or equate all the waters together and interpret, then it starts giving confusion. But if you diagrammatically represent that, the green are representing deep water, which is taken by the bore water, and these are all the waters which is taken by the shallow aquifers, maybe 150 feet below the ground, and these are all the samples which is taken the surface water body, like lake, Erie, Uranian, something like that. See, you take it over the surface of the earth. So the ratio 1 is the anions dominant Gibbs diagram, and the ratio 2, that is cations dominant nature. This is the best Gibbs diagram represents ratio 1, ratio 2. The groundwater samples of the respective areas have to plot separately against respective values to know the nature of the groundwater of the chemistry of the area. So Gibbs ratio 1 for anion, it is Cl over Cl plus HCO3. Gibbs ratio 2 for cation, it is sodium plus potassium over sodium plus potassium plus calcium. So you will have to take these values, and then after calculating every sample, then this plot has to draw. Then we will be able to easily understand the controlling parameters. Now you can say that here it is, even though it is a rock dominance, shallow water also, and here you see the movement of shallow water is moving. Deep water, it is because of evaporation dominance, and then the surface water also falls in the evaporation dominance. So you can conclude that your water comes under on which category. So this is how Gibbs diagram helps us to interpret the and its classification of the chemistry is identified by the water through this diagram. So this is the discussion for the Gibbs diagram interpretations, and the lecture is come to an end. Thank you very much.